Hey guys, welcome in Solid Design Principles series with Simply About Code. My name is Mark and today I want to tell you about first principle of solid design, single responsibility principle. I think that many developers who have contact with design principles know just how programs should be structured, but sometimes there are missing reasoning behind some design decisions. So I want to make this course a little bit different. I want to show you exact problems which you are going to face when your system architecture will be bad. I will walk you through 5 stages of simple program refactoring, which shows you the evolution of design. So in the end, you would understand why it's so important to follow these principles and why code which is badly designed will be hard to refactor and not reusable in the long run. So what our program do? Let's imagine that one day Human Resources and Finances departments hold a meeting and present you an idea of a great program which they want you to write. It should welcome new employees when they start to work in a company and also calculate how many years they have until retirement. Let's jump right in and see how our program called Company Assistant looks. On the right side in Solution Explorer you can see folders. Don't be scared, each folder presents just a new version of our program and we will go through them one at a time. So there is a constructor which takes the employee's name and age, and there are properties with the same names to keep things clear and simple. Of course, there's also handle new employee method, which is pretty short. Too short, some would say. Why is that? I just want you to imagine that functionalities presented in this method take hundreds lines of code. I think that the implementation details aren't relevant here and would distract your attention from the process of refactoring, so you would end up feeling overwhelmed. Okay, let's go and see how the program is used. It's very simple. New instance of the program is created. HR and Finance use the handle new employee method. But finances are mostly interested in the calculations inside of that method. But hey, let's run our program. This is how it looks, very creative. Now, let me quickly remind you the definition of single responsibility principle. It tells us that class should have one and only one reason to change. But our code has 2 responsibilities. First, it calculates retirements for finance department. Second, it welcomes new employees. Some would say that this line itself has 2 responsibilities because it makes calculations and prints information to the console. But to keep things simple, let's pretend that this line represents only one functionality. Okay, so this code is not following the principle. Is it something bad? I don't know at the moment. Let's see what problems we would have with this design. The first thing which comes to mind when you see a big class like that, remember to use your imagination, is to split its responsibilities into separate methods. That's a very good idea because first, it increases readability, second, it shows responsibilities. So let's see how such responsibilities split can look. So here is the handle new employee method split into 2 methods, log employee data and calculate employee data. This is a very simple way to gain clarity by splitting and seeing responsibilities. That's why it's called refactoring for clarity. But does it help with future design changes? No, it doesn't help in any way. Wanna see why? So let's assume the HR department wants to print the greeting in some funny way. That's no surprise because our program is a bit boring, right? No problem, you have FigureLib, which will do the job. Let's put it in here. It looks much better now, HR is happy. But here is what happens in real life. The finance department calls you and asks, "Hey, we just updated our company assistant and it looks kind of crazy now, and by the way, why has the size of the app increased so much? What happened?" Yeah, you forgot about people from finance, right? Now we have 2 problems. First, we have a class with 2 responsibilities, which is used by 2 departments with completely different needs. Second, when we make changes for one client, HR, the behavior of the app changes and the size increases for all clients, also finances. Don't you think forcing finance to have FigureLib on their disk is a bad idea? It can go on like that forever. For instance, months later, finances comes to you and tells you that they need to show the time to retirement in days. Easy to fix. Let's multiply that number by 365. Finances are happy now. But yeah, once again, you get hundreds of emails as the HR employees using your app on a daily basis see that workers' years to retirement have changed from, for example, 35 to 1200 something. Has the retirement system changed? What's going on? That may seem funny now, but if it was some bank account management system, this change could be catastrophic. You could say now that it's obvious that these changes will break the system. In real life, it does not work like that. The more code and methods class have, the more likely it is that someday a new developer who has no knowledge of the program will make a similarly small but catastrophic update. And if you don't have tests, it will happen sooner or later. So you would end up with a huge code base that you hate. I hope you're now convinced the design is bad. The question now is how we can refactor it. Let's recap what single responsibility principle tells us. A class should have one and only one reason to change. So class should have only one responsibility. Our has two, so let's go and split them. Here is the code after split. We have Finances Assistant, responsible only for financial stuff, Logging Assistant, responsible only for logging, greeting, and HR Assistant, named Company Assistant before, now is responsible, and that's important, only for the flow of the process. It knows what needs to be done to handle new employee, and delegates the work to other classes, each having only one responsibility. How is that possible? We hard-coded helper classes into the constructor and assigned them to properties of the class so they can be used whenever there is a need. What do we gain from the change? First, classes are much shorter, so the risk to make change which breaks the system is much smaller. Second, Finances will not get FiggleLib because now they are using Finances Assistant only, and it don't have reference to Figgle because it doesn't use it. So we're done, right? Almost. Let's stop for a minute and think how this design will handle feature requests. Let's try the change where years were multiplied by 365. Though risk of making breaking change decreased because class is smaller, developer can do one of two things. Change the method and break the system once again, or add new method and modify Finances Assistant. It seems to be a better idea based on our past experiences, right? This is a very simple way of solving the problem, but doesn't that remind you situation we just had a minute ago? If you would look at Finances Assistant from different angle, you would see that once again we just started doing two things. Doing simple retirement calculation, one responsibility, and doing very detailed accounting calculation, second responsibility. What's important here is that I don't mean that you cannot add anything to the class because it should have only one method or something. No, of course you can extend it, but let the functionalities be strictly connected with the purpose of the class. You can add some other simple calculation here, but don't mix it with very advanced ones. So, should we split Finances Assistant and take this method out? Sure, that would be a good idea. We can then use our old version here and everything will be okay. But imagine that one day there would be a need in HR to use advanced calculations. What could we do in such situation? We would probably add Advanced Financial Assistant to our HR Assistant like that. In effect, class would grow, and if such situations would happen over and over again, HR Assistant would be messy. What's also worth to mention is how we run both programs. As you can see, clients have no control over used implementation of Finances Assistant inside HR Assistant because they are hidden inside the class. Why we have such problems? Because we have, I would say, better but still not the best implementation. The problem is that we hard-coded Finances Assistant into constructor of the class and we cannot change it. If we will, it will influence all other HR companies which use our program. We say in such situations that Company Assistant and Financial Assistant are tightly coupled. It means that we cannot change one without changing the other. It seems like we are in the same place where we started, right? Wouldn't it be great if we could just dynamically define how HR assistants should behave? There is a mechanism which does exactly something like that. It's called dependency injection. Injection what? Here is how it is. Dependency, think about dependencies as things to do. Injection, because we can inject them dynamically when we create a class. Let's see some real-life example to get a better grasp of the subject. We all have USB ports in our computers. Its technical name is also USB interface. Think about such talk with computer constructor. So you want to create computer and you want to use mouse to operate that computer, right? Yeah, exactly. How can I connect it? You've got two options. You can solder mouse cable to the computer motherboard, or you can use USB interface to connect the mouse. But remember, end of the mouse cable need to have a plug which follows USB interface to be sure that it will fit into the computer USB port. By the way, here you have specification of the interface which you must implement. If such situation would happen, you would choose using USB interface instead of soldering, right? Similar discussion can happen regarding our program. You get two options. You can hard code Finances Assistant implementation into class constructor, or you can use interfaces and create classes which will fit in and would be easily replaceable, like all USB devices are. But remember, classes must follow specific interface. We can see that this is how such problems are solved in real-life design. So let's go to Visual Studio and see how we do it in code. First, I create HR Assistant. As you can see, I need to provide two arguments of type iLogger and iCalculator to the constructor. These classes will be responsible for behavior of HR Assistant. Let me create them. Let's call this one Simple Calculator. It is here because I created files with classes before, and you will see it in a minute. And here is Simple Logger, so now we can pass this implementation to the constructor and of course call handle new employee method on our object. But how is this possible that we can easily pass these classes to the constructor? Actually, it's simple. Let's see how it's done in HR Assistant. As you can see, constructor takes two arguments, one of type iLogger and second of type iCalculator, and assign them to properties of the class. Then, these properties, which are classes, are used in a body of handle new employee method. Handle new employee method in turn can be sure that these classes will have needed methods, because as you can see here, let me adjust the screen, they are implementing interface, what means that they are forced to have the same methods as interface has. Because if they won't implement them, program will not build. So in other words, you can look at interface as a contract between two parties. One, HR Assistant saying, hey, I would like to be sure that all classes which you provide to me have these methods because I use them. And other party, Simple Logger and Simple Calculator saying, hey, you can be sure that everything will be fine because we are implementing interface. So this method will be there. You can now ask, how will this design work with future changes? Basically, we have all pros of previous solution with hard-coded implementations in the constructor, but we don't have it cons. Let's see how two types of customers could be handled by Financial Assistant. First customer will use Simple Calculator, so let's create one. Then we need to create Finances Assistant and pass instance of Simple Calculator to the constructor. And of course, let's call our brilliant method which returns years. But what with second customer? He needs version of the program which will multiply years by 365. I can easily provide such implementation. Let's create one here. I will show details of it in a minute. Let's create Finances Assistant and pass Advanced Calculator to the constructor and call the method. Voila! Second customer have implementation which is a different type of calculations. What's important here is that we didn't change even one character in the code used by other customers. Let's see how Advanced Calculator looks. It inherits the interface and of course implements calculate employee data as requested in the interface. This time it makes advanced calculations. Remaining part of the class is basically copy-pasted from Simple Calculator. Now, previous customers are using old version, and new customers are free to choose which version they would like to use, and they can easily change the behavior of Finances Assistant. So we were looking for exactly something like that. Isn't it great? Yeah, so that would be it. Let me know what do you think in the comments. Remember to like and subscribe, and see you next time.